friends, welcome to the course of marketing research and analysis, the second part. So, in the last few lectures in fact we have been discussing about some of the experimental designs and the various techniques involved in experimental design such as the ANOVA and ANCOVA, MANOVA, right. These things are, they look very very complex and tough, but because thanks to technology and the use of software, things have become much easier nowadays, and it has been simple and everybody can utilize them and write very nice research papers and publish good research papers with the help of such techniques, right. So, today we will be in the last lecture we had discussed about analysis of covariance, where we said that it is a condition where it is just like an analysis of variance, but only thing is that there is an extra element which is a covariate. So, in the ANOVA you had a dependent continuous dependent variable and a categorical independent variable which is discrete independent variable, but plus in this case there is a covariate which is a extraneous variable, a confounding variable which is measured in a continuous scale, right. So, this covariate is basically required that there should be a correlation between the covariate and the dependent variable, but we do not want that there should be any correlation between the independent variable and the covariate, right. So, when this covariate is present, so how, when you control this covariate at different levels of the independent variable, what happens to the dependent variable, that is what we measure in the case of a ANCOVA, right. ANCOVA is a very powerful technique. So, it helps you to even measure the interaction effects with a controlled variable which is the covariate. So, today we will start with this example, right. So, let us go with the problem. A researcher was interested in determining whether a 6-week low or high intensity exercise program was good at reducing the blood cholesterol concentration in middle aged men, right. So, this is a very general problem. Both exercise programs, right, a high and low intensity, were designed so that the number of calories was expended in the low and high intensity groups, right. As such, the duration of exercise differed between groups. The researcher expected that any reduction in the cholesterol concentration, right, elicited by the interventions would also depend on the participants' initial cholesterol concentration. That means what? Whatever change in the cholesterol is happening, that is not necessarily only due to the exercise program, but also due to the fact another factor has to be measured or taken into consideration, that what was his earlier cholesterol level. We can't expect miracles to happen, right. So, if somebody had a very high cholesterol level before, you do not expect that because of just an exercise program he drastically reduces it and very high reduction is there. But if that is why the earlier value, the pre-exercise value is also important to note. Okay. As such, the researcher wanted to use pre-intervention cholesterol concentration as a covariate. So, before what was it? So, that is a covariate. When comparing the post intervention is the exercise here, okay. Do not confuse with the words, it is very simple. Intervention cholesterol concentration between the interventions and a control group. It is a clear case of a one way ANCOVA, right. So, you have one covariate, one dependent variable which is the blood cholesterol concentration post exercise, and what is the independent variable? The exercise, the duration of the exercise, intensity of the exercise, high or low, right. This is my two groups. So, a one way ANCOVA with the dependent variable with the post, right, which is the post intervention cholesterol. The independent variable is the group which has 3 categories. So, we have 3 categories here. So, one is no exercise, which is the control group. So, we are saying let us not give any exercise to somebody. Intervention 1 is the low intensity exercise, right, and intervention 2 is the high intensity exercise. So, one group, so let us say there are 30 people, so 10 people are asked not to do any exercise, another 10 people are given a mild exercise, and another 10 people are given heavy intensity exercise, right. And pre, which represents the pre-intervention cholesterol concentration, that means before the exercise program, what was the cholesterol level of all these 3 groups of people, or these people, right. So, how to conduct this one way ANCOVA in S spaces? So, the simple is you go to analyze, and analyze there is a general linear model. So, these techniques ANOVA, two way N way ANOVA, ANCOVA, one factor, more than one factor, MANOVA, MANCOVA, they are all coming under the general linear model techniques. So, here since there is only one dependent variable, we say it is a univariate technique, right. So, once you go to this univariate, then next is you have to take your variables into the dependent, independent and the covariate box. So, here we say the group is my fixed factor, right. So, this is what the treatment we are giving, right, and my what was my pre cholesterol level is my covariate, because that is what is affecting my condition, my cholesterol condition, and the post exercise is my dependent variable. So, after doing the exercise, what is the result of my cholesterol, that comes under the dependent variable. My group is my, this is my fixed factor, right, what group you come into. So, no exercise, little exercise or mild exercise and heavy exercise, okay. And the pre cholesterol level is taken as my covariate, okay. The next is, after doing this, what we do is we will check for the this option where we are trying to display the means, right. So, here you see, if you go back, transfer the dependent variable into the dependent variable box, the independent variable group into the fixed factor and the covariate into the covariate box by selecting each variable and clicking the relevant button. So, this is how it goes, and then we come to the options button. You see this options, this option. So, you come to this options button. So, you get this kind of a screen. So, here we will check for few things. So, what are those few things? So, first we will try to see the means for the group. So, group are 3 groups, no exercise, light and heavy exercise, and we want to see the compare the main effects. So, what is the main effect? Means the effect of exercise, right. We want to see that. Bonferroni is taken because the small sample sizes whenever the conditions are there. So, you use a Bonferroni test, right. Otherwise, you can to check for LSD and other tests are there. Descriptive, effect of size and effect size and the homogeneity of variance, these 3 things are also required, and we are checking at a 5% level of significance. You can change that to 1% also, 0.001 also, it is up to you. Now, what is the output? So, in this case I will show you first before we go to that. So, let me show you, let me take this case, I have brought the data set. Let us start, go to analyze, go to general linear model, go to univariate, right. So, you can, let us do it again. So, exercise we take it to the fixed factor, my post cholesterol is my dependent variable, my pre cholesterol is my covariate, okay. So, now what I am going to do is, I am going to, you see there is a 2 things here, you want to check your full factorial model, right. This is by default. This full factorial model actually is the model which helps you to test whether the effects of your covariate and the independent variables are they significant or not. That means the at different levels what is the change in the dependent variable, is that a significant change or not, right. So, continue, and then we go to options. Here we want to see the impact of the exercise, the display the means for exercise, that means for exercise, for when no exercise is there, when there is a high level of exercise, when there is a low level of exercise. Now, we want to compare the main effects. So, to compare the main effects you can take this Bonferroni test. Now, we want to check the descriptive statistics, we want to check the estimates of effect size and homogeneity, even you can check the observed power, right. So, these 4, now let us see what is coming. So, when we have done it, now we will see there are 3 groups of exercises. So, 15 people, and the means for the first exercise group is 6.11, then 5.57 and 5.41, right. Now, equality of variance, Levin's test is saying that there is a 0.301 means the null hypothesis which is said that Levin's test says the homogeneity of variance, that means the group should have equal variance, otherwise they should not be compared, right. So, this null hypothesis has been accepted in this case because it is greater than 0.05, right. Had it been less than 0.05, you would have rejected the null hypothesis and said ki well the variance among the groups is not same or not equal, right. Then let us come to the test of between subject effects. Now, you see we want to see the effect of exercise, right. Now, is exercise having a significant effect, right, on the on the cholesterol level? Well, the F ratio says, if you look at the F ratio, what it is 20.813, right, and it is significant at 0.000 level, 001 level, right. And if I see the partial eta square is nothing but my effect size, right. So, what is this effect size? It tells us it is like the the eta square is nothing but it is similar to the R square that you talk about in regression, right. How much of the variance is being explained by the independent variable. So, and the observed power of the test is almost 1. So, it ranges between 0 and 1. So, if it is 1, it is very strong, right, means, right. So, you see and the R square, adjusted R square is 0.694. So, the eta square is something very close, as I said, it explains similar to the R square in the regression, right. So, now we have a test where we can say easily, well, the exercise, level of exercise does have an effect on the cholesterol level of the patients or the people, right. Now, but can we say which cholesterol, which group, which exercise is having the highest effect? That means no exercise, moderate or high exercise. To do this, we have a post hoc test, which is the paired comparison. Now, let us look at the first 1 and 2, right. So, 1 minus 2 is 1.095, the difference, that means it is a positive, that means 1 is giving larger effect than the cholesterol level is more in case of 1 than 2, right. And this is a significant difference? Yes, it is a significant difference. 1 and 3, the difference is 1.624. So, again you see, when somebody has done no exercise, the cholesterol level is still higher, because it is the cholesterol level, right. Higher the cholesterol level, it is bad for the person, right. So, we want actually to be lowest. So, in this case, which is lower? 1, 2, 1, 3. So, if you see, it seems that 3 is the lowest, then followed by 2 and then followed by 1. Let us compare between which is significant? Yes, both were significant. Now, let us compare between 2 and 3, others have been compared. So, 2 and 3, if you see, the 2 and 1, it is 2 and 3, it is not coming significant, because the value is 0.098, that means much higher than 0.05, which we usually take for significance testing. So, by this we can say, well, the difference in the exercises, right, between that means no exercise and moderate exercise is significant on the cholesterol level, 1 and 3, that is no exercise and heavy exercise is significant, but moderate exercise, which was like people walking, and hard exercise, which is with machines, with machines, that actually made no significant difference. So, this helps us to test the effect of the independent the treatment on the dependent variable, right. So, this is what we have been finding, right. But the question is it enough? How do we write it now? Now, see, how do you write? So, when you write in a paper, this is how you show. So, the descriptive statistics, so this is what it shows. It shows that the mean, standard deviation and the number of participants, right. We saw that these values do not include any adjustments, these are not showing any adjustments. So, what was the purpose of ANCOVA? That it helps you to adjust for the change in the dependent variable, right, made by the use of a covariate, which is a which is helping into that, right. Now, the results, if you look at the results, now look at this. This is the pre, right, this is the group. So, group is the exercise level, low exercise and high exercise and all that, right. So, this table infers whether the different interventions were statistically significantly different, having adjusted for your covariate, right. The partial eta square, this value, right, indicates the effect size and should be compared with Cohen's guidelines. This is something which says if it is between 0.2 under 0.2, this value, right. So, these two values, for example, if it is under 0, it is a small effect. So, the effect is very little. If it is 0.5, then the effect is moderate effect. If it is 0.8 and larger, which is coming true in both our cases, that means the pre cholesterol levels also has, which is the covariate, also has a very high effect on my post cholesterol level, and which exercise category I am coming into, that also has a very high level on the post cholesterol, right. But if you see in comparison, the that means my previous condition is having a larger effect even than the exercise that I am doing, maybe because the duration of the exercise is less. If I can extend it for let us say not 6 weeks, but 6 months, then it could change, right. and it shows a large effect, true, similar to R square in regression, right. In order to interpret the results, read along the group, right, until you reach the significance level. So, this is the point we are talking about. This provides the statistical significance of whether there are statistically significant differences in the post intervention blood pressure or cholesterol, whatever, I am not a medical person. So, you can understand between the groups when adjusted for the blood pressure, that is the pre blood pressure, that is the covariate. In this example, we see that there is a statistical difference, significant difference, right, between the adjusted means, right. So, it is saying from here we can say that the effect is significant. Okay. Now, how do you report the result? It is very important, because many a times I have seen people do a test, but they are not able to write it. So, how do you write? A one-way ANCOVA was conducted to determine a statistically significant difference between the levels of the independent variables, that is in this case whatever our level of exercise on the dependent variable, which is in this case the post cholesterol, right, for the pre cholesterol level, right. So, they are controlling the pre cholesterol level. A one way ANCOVA was conducted to determine a statistically significant difference between no exercise, low intensity and high intensity exercise on the post intervention cholesterol concentration, controlling for pre intervention cholesterol. So, the same thing I have written here: exercise intensity, no exercise, high intensity, low. Post intervention is my dependent variable, pre intervention is my covariate. A one way ANOVA, this is how you write, was conducted to check the significant effect of exercise intensity on post intervention cholesterol concentration after controlling for the pre intervention cholesterol. This means you are clear, that means what was the previous cholesterol level. If you do not control it, then you just cannot compare, because somebody had a high cholesterol level and somebody had a poor low cholesterol level. Now, you do not expect a similar kind of change with the same, by giving same exercise to both these people, right. So, that is why you have to control the pre cholesterol level. Levin's test and normality assumptions were carried out and the assumptions met. So, you have to check this Levin's test, homogeneity of variance test and all this, right. There was a significant effect on cholesterol concentration. So, this is how you write. So, F at 2 and 41, this is my degrees of freedom, the numerator and the denominator, is equal to this much, and my P is this much, my significance level, due to the exercise intensity. Post hoc test, which was the paired the comparisons, right, showed that there was a significant difference between low exercise and high. This is 1 and 3, you can say, and no exercise and low, right, which is 1 and 2, right. Comparing the estimated marginal means showed that most cholesterol weight was lost on high exercise with a mean of this much compared to no and low exercise. So, this is how you report, right. So, this is estimation of marginal means and the estimate the effect of the finally the F ratio we calculate and we report it in the research paper, right. So, this is what we talk about in the ANCOVA, right. Now, I will move into another technique, which is the multivariate analysis of covariance. Now, what is this difference? It is just an extension of the ANCOVA, right, an extension from the ANCOVA. The multivariate analysis of covariance is an extension of the MANOVA to incorporate a covariate. So, MANOVA, from ANOVA to MANOVA, similarly from ANCOVA to also MANCOVA. So, you are an extension of the ANCOVA, as it says, to incorporate multiple dependent variables. So, in ANCOVA what was happening? You were having one dependent variable which was continuous, then you had a covariate and you had a treatment level, a treatment factor which had 1, 2 or 3 or 2 or more than 2 levels. Okay. Now, you are saying, well, it is like a MANOVA thing, in the MANOVA you had more than one dependent variable. So, and the presence of a covariate, right. So, this study now here, this is the clear case of MANCOVA. The covariate is linearly related to the dependent variables. The covariate is related to the, we said earlier also, the covariate should be having some correlation between the, there should be some correlation between the dependent variable and the covariate, and its inclusion into the analysis increases the ability to detect the differences between groups of an independent variable. I am sure by you have understood by now, in the last example also when I explained how the treatment levels, that means the exercises, were affecting the post cholesterol level, but then just saying that and not including the what was his pre cholesterol level will be wrong. So, if you take the pre-cholesterol level, what was his, suppose for example somebody's weight, how will it change with exercise? But suppose you do not consider his earlier weight and you think everybody should be coming down to let us say 60 kilo, but actually somebody was 90 earlier and somebody was 70 and you expect both of them to be coming to 60 is wrong, right. So, that is why the covariate is very important, right. Mancoba is used to determine whether there are any statistically significant differences between the adjusted means of 3 or more independent groups. That means, in one factor there are 3 groups or more than that, having control for the continuous covariate, right. You could use Mancoba to determine whether a number of different exam performances differed based on test anxiety levels among students while controlling for revision time. So, let us see this example. That is, your dependent variable would be what is humanities exam performance, science exam performance and maths exam performance. 3 exams are there. So, 3 dependent variables are there, right. All measures from 0 to 100, how much score a student has scored. Independent variable would be the test anxiety level, which has several levels. What are they? 3 groups: low stress students, moderately stressed students and highly stressed students. So, we are trying to see whether the stress level of the student, does it have an effect on the exam performance for humanities, science and mathematics equally or is it differently, right. So, let us see that, but here if we do that, then suppose some student has already done a lot of revision work and somebody has not done any revision. Will the performance in spite of being different levels of anxiety, will the performance be the same? No, because if somebody is well prepared, his chances or her chances of performing better in the exam at whatever level of stress may be is always better, right. So, and your covariate would be the revision time, which is measured in hours. You want to control for revision time because you believe that the effect of test anxiety levels on overall performance will depend to some degree on the amount of time spent on revision. Okay. So, assumptions are more or less the same like ANCOVA. You have your 2 or more dependent variables should be measured at as a continuous variable. One independent variable, if it is a one way MANCOVA, then it is only one independent variable, consists of 2 or more categorical independent groups, right. Your 1 or more covariates all are continuous. Okay. So, what is a covariate? Again, a covariate is simply a continuous independent variable that is added to the MANOVA model. MANOVA, in the MANOVA there was no covariate, if you add a covariate it becomes a MANCOVA, right. There should be a linear relationship between each pair of dependent variables. So, if there are more than one dependent variable, there should be a strong correlation between them. Within each group of the there should be a linear relationship between each pair of dependent variables within each group of the independent. That means, independent variable we are talking about is the factor levels of the factors, okay, levels, right, factor levels. So, there should be a relationship between the dependent variables. There should be a linear relationship between the covariate and each dependent variable. There should be within each group of the, but there should not be any within the covariate and the independent variable, right. It should be at different levels of the independent variable, there has to be a correlation between the covariate and the dependent variable, right, simple up to this much. Homogeneity of regression, again like ANCOVA, has to be checked, okay. Homogeneity of variance and covariance have to be checked. There should not be any significant outliers, okay, that was also the same, right. There should be no significant multivariate outliers. So, well, this is both for outliers, so we will keep it normally, and normality should be present. And one more thing, missing data should not be there. If it is there, you kindly correct. So, if it is not normal, if it is skewed, kindly transform the data. If there are outliers, you may remove them or you may correct them, right. If this not homogeneity of variance is not showing, kindly think of transforming. If there is no homogeneity of regression or variance across the groups, then you can think of transforming the data and trying to see whether it is coming or not. If still it is not coming, then maybe statistical tests, parametric tests are not applicable, right. Now, take this example. A researcher wanted to determine whether cardiovascular health was better for normal weight individuals with higher levels of physical activity, that is as opposed to more overweight individuals with lower physical activity levels. Okay. As such, the researcher recruited 120 participants who were subsequently divided into 3 groups depending on the amount of physical activity. So, each group let us say was a balanced group 40, 40, 40, right. A group who were classified as engaging in a low amount of physical activity 40 people, group who were classified as engaging in a moderate 40 people and high amount of physical activity another 40 people. There were 40 participants in each group. In order to measure cardiovascular health, the researcher took 3 measurements from the participants. It was expected that increased levels of physical activity would have an overall beneficial effect on the cardiovascular health as measured by cholesterol concentration, C-reactive protein and systolic blood pressure. However, the researcher knows that body weight also affects the cardiovascular health. So, if your body weight is high, your chances of having a cardiovascular problem may be high, right. As such, the researcher wanted to control for differences in the body weight of participants. Just understand, just imagine, had he not taken the body weight, then it would not be justice, not be the right way of doing a research, right. You cannot say that any body weight the effect of exercise of on the heart of people would be same for all types of body weights, right. No, it cannot be true. So, what is next? How to conduct the Manova and SPSS. So, here go to a general linear model. Earlier when we are doing ANCOVA, we are going for the univariate, but this time since we have more than one dependent variable, we go for the multivariate. Okay. Then you take all these variables as earlier we had done. So, we have taken let us say cholesterol, the CRP protein and the blood pressure as a dependent variable, the group which group of activity he was coming, that, and weight is my covariate, right. Now, you can similarly I am just showing you, then I will show you a real case. So, the same case on the SPSS. So, the group we will take the group, the intensity of the exercise into the this side. So, to check the display of means, it is within the multivariate options dialog box, so that you can instruct okay, this is now take this and finally compare the main effects and we check for these 3 things, the effect size, descriptive statistics and the homogeneity. So, we know we want the mean, median, standard deviation and all these things, mean, standard deviation, the variance, equality and the eta square or the effect size, right. You can also take the observed power to see how strong your test is, how powerful your test is, right. So, as I said, if you remember during ANCOVA, if you have a good covariate, it reduces the mean sum of square within the test. So, that is why if you have a good covariate, it reduces the MS within and thus increases the F ratio. So, thereby what happens is your power of a test, the beta reduces, the beta is the type 2 reduces and your power of a test statistically significantly improves. Okay. Now, click on the continue button and get the results, right. So, how to interpret the results? Before that, let us try to do it on the SPSS. So, I have a MANCOVA, right. So, we go to the general linear model univariate. So, I have done it, right, we can reset. So, I take all the 3 group as my fixed factor, cholesterol, CRP, SBP, blood pressure, and this as my covariate, correct. Now, I will go to straight away, I will go to the full factorial model, it is by default. Now, let us go to the sorry, not save, I do not want to save anything in fact. So, I want to see the group means, right, group means and compare the main effects, right. So, you can Bonferroni, you can, if you keep LSD, it does not make much of a difference because your sample sizes are not large, that is why we are the Bonferroni actually takes care of that small sample size, it adjusts for the differences. Okay. So, but if your sample size is good enough, then you can go for even CDAC or LSD, right, and we want to this, right, even observed power if you want you can take. So, this is all, now run, let us run. So, if you go to the output now, so let us look at it. So, what is the my dependent variable? So, dependent variable cholesterol, CRP and SBP and 3 groups were there, high, low and moderate exercise for all the same, right, and look at the mean and standard deviation, right. So, if you see the cholesterol for the overall cholesterol was 7.5, CRP 14.34, SBP 128. The highest cholesterol was for the people who are doing high exercise, but here remember we do not know particularly well because the covariate also is one that has to be taken, right. People with a low exercise is the mean cholesterol level is 5.87 and 7.15, this is CRP similarly 36, 2.5, higher the protein risk of heart disease may be high. I do not know high or low, maybe I am not a doctor, anyway we will only go through numbers. Okay. Now coming down, so in fact this Boxham test, it tests the null hypothesis that the observed covariance matrices of the dependent variables are equal across groups, but in this case our data is not showing a good sign. It should not come significant actually, please note it down when you write, because you have to write it in the research paper. It should actually be more than, because 5% level of significance, it should have come at least above 0.05, but in our case it is coming 0.000, which shows that it is significant. That is actually should not come, because I have not treated my data. So, I have brought it as it is. So, whatever is coming it is shown here. So, you should ensure that it is above 0.05. If there is not, then you have to maybe go to the data set again and check and maybe collect more data. My sample size is also less here, right. So, because if you see my sample size how much it is much less, because we expected 120 in the group, but we have only 45 I believe, right. So, you do not expect the same result, right. Anyway, just understand it, right. Now, we will go to the multivariate test. Now, if you want to see the effect of the weight. So, first, since it is remember when it is non significant, you should, there are two options here, basically we go for, if it is significant then we should go for the Pillai, if it is significant we go for the Wilks lambda, if it is not significant then we go for the Pillai stress. So, here we will go for the Wilks lambda, and here we see that it is significant. So, weight has a significant effect, right, and the effect size is 0.387, which is, as I had said, it is close to, is similar to the regression in the R square in the regression, right, and observed power is 0.986. This is the effect of weight, the covariate. Now, the effect of the group, that means the exercise, how much is it? Is it significant? Yes, it is significant, right, and but if you see the earlier weight of a person has got a larger effect on the final dependent variable than the type of exercise, right, and observed power is 952 here, right. So, this is Levin's test, should have come, actually this none of them are coming significant, but it should have actually for a right Mankova test or a Ankova test, the Levin's test should be above 0.05 or above your significance level, right, which is not coming here. Now, coming to the test of between subject effects. Now, let us look at it. Now, we are again see weight, we have seen, is it significant? Yes. Weight, cholesterol at a particular, by controlling the covariate weight, okay. Is cholesterol significant? Yes. Is CRP significant? No, CRP is not coming significant, right. Is the blood pressure coming significant? Yes. So, when I am controlling for the weight, so my cholesterol is coming significant, my blood pressure is coming significant, but my CRP is not necessarily coming significant. When I look at the group, right. So, when I look at the group, I will see so group, is it significant cholesterol? No. Is my CRP significant? No. Is my blood pressure significant? Yes. That means the type of exercise is having an effect on these three. So, obviously my eta square, if you see my power of a test will also fall down drastically, but however it would have been higher, I would have been more happier, right. Now, you can see the pairwise comparison, this is the post hoc test, right. So, when I am looking at cholesterol, right, I am comparing cholesterol high and the group, what I am comparing it is against the high cholesterol, and I am comparing it in low and moderate exercise, right. So, cholesterol low, high, moderate, cholesterol moderate, high and low. So, when I am taking this dependent variables and I am comparing, so I can find out the mean difference from here and I can run the check the significance. So, where I can, then I can say which is having a significant effect and which is not having a significant effect, right. So, but ultimately this is what is the final. So, let us go back to the interpreting the results. Now, the result values might not be the same here, this is only for writing. So, the main purpose of running a one way Mankova is to establish whether the groups of the independent variables are statistically different on the dependent variables after controlling for a covariate. If the one way Mankova is statistically significant, this suggests that there is a statistical significant adjusted mean difference between the groups of the independent variable in terms of the combined dependent variable. So, this is what you saw in the last slide. So, this table I am talking about, okay. And look at this. So, this is the weight and the group. Now, we will see this group effect. For example, we are only interested in the effect of the group. So, if you look at it, is it significant? Look at it, yes, it is significant, right. So, that is what you report, and this is my eta the effect size, right. Note, we have highlighted the rows within the group heading as you saw. The row heading will have the same name as your independent variable. In our example, it is labeled group because this is the name of our independent variable, right. So, exercise or group, whatever you want to give. When you analyze your own data, look for the row heading in the multivariate test that matches the name of your independent variable. The different names given to each row, Pillai's trace, Wills lambda, Hoteling's, and there are the names of different multivariate statistics that can be used to test the statistical significance of the differences between the groups. But generally we use the Wills lambda, right. For Pillai's this Roy's largest root is also used, but it is a highly sensitive to the normality assumption. Each different calculation will provide you the probability of getting an F statistic greater or equal to the one calculated, that you want to compare with the calculated and the table value, right. It also provides you with an effect size, right, the eta square. So, which is like this. However, you have added the complication of having to decide which multivariate F statistic to use, right. The most commonly recommended is the Wills lambda. So, this is I would have said it, but I have kept it in the PowerPoint so that you can later on read it and understand it. Therefore, the result for the one way Manitoba is found along the Wills lambda. So, go across this line. So, what is it saying? Is it significant? Yes, the eta square is this much, okay. So, when you look at the Wills lambda, the you ignore all the other things, right. So, when you analyze your data, you will have an intercept row heading. So, these things but since weight reflects the name of our continuous covariate weight, this heading name will be different. It will have the same name as your name of your continuous covariate. So, forget this part, this is what we require. If the one way Manitoba is statistically significant, so what you found, you will have a p value less than 0.05. However, if p is greater than 0.05, the one way Manitoba is not statistically significant. In our example, there is a statistically significant difference between physical activity groups in terms of the combined health variables after controlling for weight. Alternatively, if p is greater than 0.05, this is not a statistically significant difference, right. So, between the physical activity groups in terms of the combined health variables after controlling for weight. As such, you need to consult the significance column and along the Wills lambda row, right. So, this is what we have shown earlier also. So, this is written. So, that is there are statistically significant differences in the combined health variables between physical activity levels after controlling for weight. SPSS statistics will also report an effect size called the partial eta squared, right. Okay. So, this is also I have shown. Now, how do you finally write? So, you write like this: a one way Manitoba was conducted to determine a statistically significant difference between, you have to write the original, the name between here, for example, what is our independent variable, the type of exercise, on the cholesterol, CRP and SBP, right. So, these are my dependent variables. So, you write the levels of the dependent variable, cholesterol, CRP and whatever the third one, BP, right, blood pressure. Controlling for what? Not the weight, right. So, this is how you write. A one way Manitoba was conducted to determine a statistically significant difference between low, medium and high exercise on the cholesterol concentration, C reactive protein and systolic blood pressure controlling for body weight. There was a statistically significant difference between the physical activity groups on the combined dependent variables after controlling for weight. Now, this is how you report. F 6 to 28 are my numerator denominator, the degrees of freedom, and my F value is this much, P is this much, Wills lambda is this much, eta square is this much, right. So, physical activity groups. So, this is already explained. So, this is how finally you see this table, right. If alternatively the one way Manitoba was not significant, you could report the result as follows. Suppose sometimes it is not significant. So, what is your mistake? So, it is written there was no statistically significant difference between the physical activity groups on the combined dependent variables after controlling for weight, this is same, right, is equal to this much, P is this much, Wills lambda is this much and eta square. So, you have got that, you remember. So, this is my final. If you just to show this one, you can go back also and check the table value, right. So, individually for the groups we had seen, we should go to the output table. Now, if you go to the output little up also, you can see it here, right. So, does this group was the group effect significant? Let us say Wills lambda, we will see is it significant? Yes, right. So, we can see here, and then from here, from this you can compare the test of between subject effects, right. So, now we will stop here. I am sure you must have got some insight at least into the details of ANCOVA and MANCOVA, which is nothing but similar to the extension of ANOVA and MANOVA, right. MANOVA is sometimes called as a mirror image of the discriminant analysis, that is a separate story, I will explain sometime, right. But I hope it is clear to you. If it is, there is some doubt in your mind, you can question me and I will try to help you out. But remember, it is a very important technique, these are very important techniques and they are very useful, and you can really do wonderful research work if you can understand these statistical tools, right. I hope this is all for the day. Thank you very much.